I'll continue the Eiffel for beginners, and I guess you can start then, Emil.
Yes. So my name is Emil Bäckmark. I work for Ericsson in Linköping. I've been working with Ericsson since 1998, and I've been involved in Eiffel since 2016, 17 somewhere, when it was open sourced, among that time, mainly. That's what I say. Let's get started. I will now give some background on Ericsson's use of Eiffel, some introduction to why Ericsson uses events at all, and then talk about the different use cases. The background of the use case number one is provided by Christopher Hallén, and I expect him to be online in the meeting. He couldn't come here in person. So if you have any questions, he will answer all of them, for the background and the use case number one. I hope I present it in a good way anyway. Then I will present the second use case that I myself provided. So some background on Ericsson's use of events. Ericsson loves events in CI/CD. We already heard in the beginning that we have been using events since 2012, somewhere around that. We created the first edition of the Eiffel protocol internally, which was proprietary at the moment. And then we open sourced it in 2017 or 16, 17, somewhere there. An architect in Ericsson for CI/CD said that there must be something that we did right, since we're still getting value from concepts we defined tens of years ago. And the current situation in Ericsson is that we send a couple of millions or 3-4 million events per day in Eiffel. We use them for connecting pipelines to trigger things. We use them to collect product information. We use them to provide data for visualization of products and pipelines. So when we say CI/CD pipeline, what is a pipeline? And this is something that you probably often see. You commit some source change, you trigger some build, you notify about the build outcome, you run some tests on it, you notify about that outcome, and then you deliver it, and you maybe deploy it to some production, and often it's a straight line like this. Our reality is not really like that. It's more like this. So we have dependencies interleaved here and there, components and subcomponents delivered from different places and try to be integrated in different ways. So our situation is not really like it is in the books. In our world, we have thousands of software components. We commit thousands of times per day in all these software component repositories. We run hundreds of thousands of tests on these days, on these commits. We are more than 1,000 developers on 3 different continents. We are migrating from embedded systems to cloud platforms. And we are using also physical radio signals in our solutions, so therefore we need to adapt our solution to that physical reality. And then we have maybe about 40 different development and CI/CD tool stacks. But all of this should result in one system, one solution delivered to the customer. And that solution should have high availability with the 5 nines there. It should be possible to deploy on cloud or on-prem on your own hardware with your own circuit boards, or our own circuit boards rather, still working with the physical radio. And nowadays it will also work. We need to deploy things in the public cloud as well. But our thinking there, and I know Magnus was into this as well, we will never have the same tool stack for everyone. Not for all developers, not for all CI/CD systems in our massive solution. And manual orchestration obviously doesn't work better. So looking into a couple of use cases then, I will present these 2 different use cases. The first one I call software pipeline assembly. How we manage to assemble a huge software pipeline in days. And the second one I call dependency updates, and Magnus was into that as well. You might know about the Pendabot if you're working in GitHub, or maybe Renovate if you're working elsewhere. I will describe another solution based on Eiffel events. So, software pipeline assembly. So, the starting point here, a couple of years back, we had two main big tracks in Ericsson providing two different solutions. One, you can say on the top there, the more on-prem or the bespoke hardware platform solution, which has been there for many, many years. And then some years back, we started to deploy or implement a cloud version of our radio access network, or RAN. So we have had these two different tracks going on with different projects, different CI/CD systems, different setups, everything. And then we got the challenge then a couple of years back to merge these together to make sure that parts of the different solutions could be interleaved with each other, and we could provide one solution to the customer that manages both the cloud setup and also the legacy version. So we call that the one radio access network, the one RAN. And this should be done by still keeping the existing flows. So the old isolated ones should still be there, but the new one should be there as well. And we managed to do that thanks to events. So thanks to that, we had decoupled but connected pipelines in all these steps. We managed to, in a few days, just rearrange these pipelines and create a new one, duplicate it, and set it up so that we can make use of the different components for the different deliveries. All of it could also be visualized more or less out of the box, since we had everything set up. So just adding another production line here with this combined solution didn't really affect that possibility. We could still collect product information for all these three different variants, and we collect quality information as well. And as I mentioned, it was fast. We made it in just a couple of days, actually. And it was obviously then cheap as well. With minimal impact on existing pipelines, because those were still running, not knowing that there was a new EI in town. So some reflections on this, that it helps if you have infrastructure and best practice and schema governance or central ownership of it. We can't say that we're best in class in that area. We might come back to that later, but it helps if you have it. And also some use cases might be more important than others, so focus on the things that you get most from, and you can evolve, as I also mentioned earlier in the day. A question from Emil. Yes.
What do you mean by ownership when you central ownership? What is that?
Yeah, I mean, if you have different organizations within your, or sub-organizations in your organization that send information, it's someone needs to make sure that everyone speaks the same dialect, and that you own the interpretation of the data that is created and I mean both produced and consumed. We will talk more about that I'm pretty sure in different sessions later, but having a group that centrally controls those things and I mean document on system level how these things should work helps out a lot. So that's the central ownership or governance, which we are hoping to have in a better way. Thank you. So the second use case, the dependency update use case, this might be very, very easy to grasp now, I hope so. I created a very simple setup with an ice cream and a cupcake. And as you see in the ice cream there, it consists of different ingredients, and obviously there is a strawberry module in it. And the cupcake has both a strawberry and blackberry module in it as well. So they're quite similar, both of them are strawberries, so they share one of the same ingredients at least. That's the setup here. So if you were to deliver a module as, say you want to create a new version of this strawberry, new version of the module S. You commit the source code. It's probably tested somewhere. You merge it in your source code repository manager. You do some build on it and test it again, and then you deliver it. So you have a new, fresh version of module S. Then obviously you want to use that new type of strawberry and see if it fits in your ice cream and your cupcake, and it works out well there. So you have a similar thing on top of the strawberry delivery. You will then deliver a new version of the ice cream and the cupcake. I think this is quite obvious that this is what we want to do. But what happens then? Many times today, this is what you do manually. So you somehow realize that, hey, there's a new version of this module S. Either you get mail about it, or you see some friend that provides you with these new strawberries, or in some other manual way, and then you yourself trigger the activity to integrate it in the ice cream and the cupcake. What we did here, since we have events that can declare that, hey, a new module S version is delivered, we can automate this upgrade. Or we call it uplift of them. So we created a plugin to our CI solution that we are working on, which it's a dependency update plugin there, which can automatically then listen to these events and update the version files or the product information in those higher order products, let's say, and deliver them as new source code changes in both the ice cream and the cupcake case. And obviously then as well, if we see at the BlackBerry module B there, it will also send events and say that there is a new version of the BlackBerry, and that will then also trigger an integration, but only then for the cupcake. So we can separate that. And it's defined in each product I or C here, which events should I listen for, and what transformations should I do on my version files, or my dependency files, to make sure that I get this new version into my solution. And then our dependencies doesn't look as easy as these ice creams and cupcakes. It's a bit more messy than that, but with a solution like that, with these integrations happening automatically, you can actually manage things like this as well.
A question.
Yes.
How do you manage it that you want to test the other products before you deliver the first product?
Yeah, good question. So you can have the laser pointer. You mean that you test things? You want to test this product before you deliver the second one, or you want to?
If you want to test product I, that it really works in just product I and product C before you deliver module S.
Okay.
You don't want to
So you want to integrate some testing happening before the merge, before you actually merge it into the main line of the module S there. Yeah, then of course you need to have a test system set up with some variant of the product I and C, where you can bring in that without having so maybe you make a kind of pre-delivery here internally. You publish that not yet merged version into some repository you have, and you make that available for these different products. So we don't just send events when we deliver it, we send events all over this pipeline. So you can trigger on whatever event. You can trigger on just the build, if you want to be an early adopter and say, I want to integrate this even though it's not yet tested. Or you can even trigger it before it's merged then, but then you need to refer to the pre-merge, or if you talk Garrett terms, it's the source change that exists in Garrett before it's even merged. So there is a reference, of course, to that one, and you can download it, you can clone that version and test it in your own integration.
One question also related to when you deliver something from module S, and that delivery was a promotion. It's really the same artifact, so to say. And to save time, is there some thoughts around avoiding certain type of build, since really it's the exact same product that you're looking at from Eiffel perspective, or is that?
Yeah. So what this delivery is in actual Eiffel events, I don't state it here, and it's up to you to define it. And it could be a certain confidence level, for example. If you call it promotion, that's perfectly fine to call it that as well. So you can decide to integrate this on the very earliest promotion level you have, or you can say, I want to wait until it's promoted to the highest grade before I integrate it. So it's again up to the persons responsible for this product I to describe what am I dependent on, not just what modules, but also what characteristics of those modules. Should I integrate just a very confident version of it, or should I could I integrate an early version of it?
So one thinking was that if we take the earliest version of this artifact and then we already integrate it, but we're not still sure that it passes all the tests in other contexts, but we still try to be as early as possible. And then when we realize, okay, this is really good to stable artifact from module S, at that point we have really already included it in a later pipeline, so to say. And if there was a way to, from Eiffel perspective, that we can look at build avoidance, to not have to do the same thing again that we will repeat, or is that?
Yeah, I think there are maybe some way to do it with Eiffel aspect itself. There is an event called Artifact Reused event, where you say that, well, there is a new version of this product, but I reuse. I don't really rebuild it. I just state again that this is the same artifact that I built recently, and points to it. That's one way. Otherwise, it's not really. I mean, it could be made outside of the Eiffel aware part as well. I think the build avoidance. But I agree. It's a tricky thing when you want to test a full integration of something that you don't yet want to commit or merge in the very early parts. So I would say you shouldn't be afraid of publishing new versions of, so say, lower level components. You should be able to throw them away if they don't really measure up later on. You shouldn't consider all of these deliveries to be customer official facing. We have had similar discussions internally, and actually, I'm not sure we have really finished them. I mean, still there are people wanting to have multiple integrations down the line before they actually merge something very early in the pipeline. Yeah.
But isn't that more, not so much an event problem, but more a test environment challenge? Because when you build module S, it could definitely be tricky to set up a test environment to also test your new module S with product I. That's definitely could be a hard problem, but I don't think it's an event problem.
No, not really. No, I don't think it is. But it's a problem, sure. But it's maybe nothing that we solve directly just with the event protocol itself. So I think I spent my 20 minutes there. And it's up to Magnus then to continue on some Axis use cases.
I could relax until lunch, but no. Okay, so I'm going to talk about some of the things how we use Eiffel in Axis. We do use them similar to what Emil described in Ericsson for updating dependencies, but I'm going to talk about a very different way of using. We're focused more on the observability aspect of it. So to some extent, our build pipelines could look like this. I mean, we as I mentioned earlier, we have around 100 products that we currently develop for. So to some extent, the pipeline for them could look like this. You build one product, you test that product in isolation. You build another one, and you test that one. And you do that any number of times. That's not terribly tricky to set up a pipeline for that. But this is a gross simplification of reality. It actually looks like this, where different teams, they want to test different aspects and different test scopes. Our products, they have very different features. You have different chipsets, different CPUs, different drivers, different what have you. And the team working on some specific functionality, they don't want to, and they can't test on every conceivable product. So they choose some subset of products that are relevant for the code that they're touching. Ideally, you would choose the test scope automatically based on where a particular commit has changed. So we have a number of different pipelines that need to be configured. The teams would own what products they want to build for and what test scope and so on. But in terms of actually owning the configuration of, in our case, Jenkins jobs, part of that needs to be owned centrally, because teams, they only want to provide like the configuration, high-level configuration of what they want to build and test. The small nitty-gritty details will be taken care of by the tools team. Another problem is fan-ins, which, for example, Jenkins doesn't support at all. We have cases where you build multiple products and they get combined into one binary that then goes through a test. A third case is testing of systems, where you reuse the same binary in multiple tests. You could also have a case where you don't only test newly built software. You also pick up pre-built software from, for example, the most recent LTS, like in the case of the B prime. So you want to test a freshly built C with an old B and make sure that they're still compatible. Again, doing this in Jenkins would be very, very painful. So what we're doing here is we are basically implementing the execution of the desired graph of jobs. We are implementing it ourselves instead, because we need more flexibility than what Jenkins really can give us. Another option would be to use a completely different tool as well, but that would have come with other consequences that would have been problematic. So we basically have one root job that starts all the other builds in a Jenkins pipeline. That's not terribly difficult, really. The problem is, if you would visualize this in Jenkins, it would look like this. Technically, all the builds have the same parent. So you could have hundreds of these builds on just a flat, and the hierarchy that you would have here would be completely lost. So I mean, you can't show that to users. It would be hopeless for them to understand what's going on. So to address that, we are basically ignoring the Jenkins UI, and we're not going to, promote our users to use it. And instead, we have our own interface, which is driven by Eiffel. We already get Eiffel events from Jenkins, so it's just a matter of just a small matter of programming, of tying them together and displaying them in a graph like this. So to the left, you have the W products. They are combined into one package and tested together. But most of the other products are just built and tested one by one. And so most of this is an actual screen dump of the prototype for this tool. Down on the right, I've added a few things that don't exist yet. But it's pretty useful to have. We have, during our tests, we run things on the side, not in the main sort of test process. So we have separate services that, for example, downloads the software into the devices prior to the test, what I'm calling upgrade here. That's done as a separate service for various technical reasons. They need access to, you know, network switches and so on that we don't want to provide access to in the regular test processes. So it's run completely separately, and instead of, for example, streaming the log from the upgrade to the test job, we can model it as an Eiffel activity that we can tie into this graph. So, for example, you could click on the upgrade box and look at its logs. We also have side activities for collecting crash dumps. If a process in the device, or maybe the whole kernel crashes during the test, we want to know about that, obviously. We want to connect it to the currently running tests so we can present to the user that this particular test, when you did that, the kernel crashed. We also have general collection of the system log during this process. And again, if we do get a system crash, that could be exposed through the crash dump collection activity, the sub-activity of the actual test. And you could click that box and get the artifacts like the crash dump. You would be able to access the log of the activity and so on. And the tool that visualizes this doesn't really need to be aware of any of this. It just knows that there are a bunch of activities. They are connected in this way. Some activities expose artifacts, and some activities have logs and so on. So it's a really nice way of sort of building a more modular pipeline that doesn't need to be aware of all the details. Yes, I think that was the final. Any questions about this? Yes, go ahead, sir. Let's see. We get a microphone.
Yes, given this garden segment visualization, there has been a use case in my previous organization that constantly, especially in the test pipelines, we have to rebuild. So in the concept of visualization, how this can happen so that it contains like historical data, what's like is something covered by Eiffel, like by connecting like this properly? Or
no, you could. Okay, so the question was, can you, if you do rebuilds, can you visualize that? For example, yes, you could. Last year we introduced a link type called original trigger, which is basically a way of saying that this activity is a rebuild or a retry of this other activity, which is sort of what you're asking, it seems. So yes, that would be possible. So for example, if you would, in this case, if the original build of the P7304 failed, you could, I mean, that will be up to the visualizer. Should I even show the old one? Maybe the original failed one is completely, irrelevant. Maybe I should just hide it, or maybe it should be hidden behind some menu or something, so you can still look at it. That's doable. You could also link. There's a way of linking activities in time. There's you can link to a previous activity execution. It's a little bit underspecified what previous actually means. Is it just the previous one in time? Is it the previous one with exactly the same configuration? What does it mean? That's less defined than what I would want it to be. But sure, you can, if you can pick a definition of what a previous activity even means, you could definitely use that to add to a graph like this to make it more possible to explore. Another aspect of if we look at, let's see, this one, if you have just one root job that really runs everything, then the aspect of looking at, if you have like your private job and you're running it like once every night, for example, then you can easily just go to the previous job and see, well, this, I have job 1, 2, 3, and then job 1, 2, 2 would be the job or the build from last night. If you have it like this and everyone runs the same job, that doesn't make any sense at all. You would have 10,000 instances of this build every day. So it doesn't work. So, but Eiffel allows you to add that kind of navigation ability between these activities. making the sort of the physical representation of the builds, in this case in Jenkins, would largely be irrelevant. Of course, it also means that you might have to replicate more of the Jenkins UI than we would like, of course. But a lot of it is probably not relevant to the users. They are mostly interested in if my build failed or if my test failed, give me all the information that I need. And if you have test results in a separate tool, it would possibly be easier to visualize that information here than to get it into the Jenkins interface, for example. So this kind of observability is really helping us build our next generation of CI that works for us. Any other questions? Emil?
Yeah, you talk about the users here, and I guess that's the developers.
Yes.
You also work with the other end, or what to call it, the ones that receives the product at the end, or wants to understand how stuff work or in the organizational process in a bigger picture, not for a single developer. Did you understand that?
Not really.
No, I understand that. Not really. So if you want to understand the big flow, not the specific things for you,
Right. Okay. Yeah.
understand the big picture, how does the development process work? They work with that kind of visualizations.
Yeah. Well. Yeah. Yes. In a way, this looks like just one instance of build and test execution, but we do use Eiffel for like the whole the daily releases of what's on the master branch, for example, and its promotion through the daily and weekly test loops, for example, and how things progress there. But there is no, in terms of like expressing the general development process. That kind of generalization is, I don't think Eiffel is really the best tool for that. You can observe like concrete instances of things, like snapshots in time. But if you want to show like the generalized, well, then you would have to aggregate the events in some way. I'm not saying it's impossible, but clearly it's not something we're doing. No. Yes, sure.
Is it possible to have an expiry for an event? You progress it.
Put in expiration?
Yeah.
Because
if it started and it's never ended, then it would mean that something went wrong.
Yes. That's nothing built into it. And that's actually one of the challenges of, we've tried to make entirely event-driven pipelines where we just, as Emil spoke about earlier, we say, oh, here's an artifact, and then we just hope that someone picks it up and does great things with it. The problem is, that's sort of the downside of too much decoupling. Then you have no idea. You don't even know who is supposed to pick this up. And that's where you can't really do it entirely event-based. And that's one of the problems, indeed, that, when do you know when you are done, and when do you know that something's gone wrong? That's a challenge if you want to go completely event-based. So I usually don't recommend it. So what we're doing in this case actually is to implement the execution of this. We could have done it like we build the P7304, and then we have some other independent process that just says, oh, someone built the P7304, let's test it. But again, we have no idea what's going to happen. So what we do is we build the desired execution graph at the very beginning, and just actually publish it as an artifact, saying, hey, well, here's an artifact that describes an execution graph that you might want to execute on. And that sort of acts as it sort of primes the whole thing. So the visualizer would interpret that data and could draw this graph, most of it, right away. But it doesn't know about the one with the red border, because those are more like dynamic. So they would pop up afterwards. But it's probably a good idea to have an orchestrator that would know more about the system and what actually needs to be done. But again, you can still use events to observe what actually takes place and when and so on.
maybe you've answered it, but do you have any way to visualize that P7304 there takes 10% longer time this week than last week, the week before that? So we have server issues, whatever issues.
Yeah, we don't do it. We could do it, definitely.
How can you do it? How can you refer back then in time? How can you identify the build 7304 between different threads?
This goes back a little bit to the question of previous activity execution. So it's sort of like how do you do, what should you compare things with? You could use the activity name, perhaps, if you have an activity name that in this case it's just that, but if the parent of all this has a name that you could use like the common key, that's one way of doing it. Or if you design the previous activity execution in a way that that build links to a previous activity execution that was like last night's build, if you want to be tracking night by night, for example. So it's or you connect them entirely outside of Eiffel. But if you want to do it with Eiffel, I would say either activity names or, well, actually, you could use what's called a flow context, which is a way to sort of bind together events and group them in another way than with compositions. You could say that, you know, this event belongs to a particular release track or a particular product, and you could probably use that in this context as well. And once you have those bindings, you would have, you know, someone would process the stream of events and figure out the distance in time or the execution time of a particular activity compared to last week. Or you just generate metrics of all of it and you use some, I don't know, anomaly detector or something on the time series to do that. That's, yeah, many ways of doing it. Okay. Did you have a comment?
No.
No. Oh, good. Anything else? All right, thank you. So should we do the landscape now? Do we have time?
We do.
All right.
Yep. So my name is Mattias, working at Ericsson, and I'm going to talk about the landscape that we have. So this is just going to go through the different type of components we have in our repositories. So how to find it? If you go to the GitHub community page and you go to the community link here, you will find this landscape here. And this is how the landscape looks. Now, you might notice that we've got some things that are called graduated here. And let's go through a little bit what we mean with that. So within the Eiffel community, we've got a life cycle for all our projects. The first stage is sandbox. And this is where if you're a new project coming in and you're doing heavy development, you want to signal people that, okay, this is a pre-development. Also, if you only got one organization that is actually developing it, it's a sandbox. Graduating, this is where we're saying to people, okay, this has got some quality, you can use it in production. And also that we've got like 2 organizations who were actually maintaining it. We also got archive. This is a signaling that we actually probably don't have all the maintaining power to keep it up to date. You can then get it back to graduate later on. So if we go through the landscape, we've got a couple of plugins. We've got 2 different Garrett plugins. One is developed by Ericsson and one is developed by Access. And as you notice that the second one here, it has got a little error, so that one is hosted within the Garrett plugin location. They work a little bit differently. And they also support different Garrett versions. We also got an Eiffel broadcaster plugin, Jenkins plugin, hosted then in the Jenkins plugin repository. We've got to get started. We have something called easy to use, which is the idea to get you started. So basically you can download it and boot up a couple of Docker images and try it out. You can also use Kubernetes for this if you want to. We've got a couple of libraries. I'm going to go through a little bit more of these ones later on, so I'll skip ahead. We've got a bunch of community and support repositories. These won't actually graduate because they don't make any sense of them graduating actually. So in the community, you'll find like meeting notes, you'll find the PDFs from these summits and also the governing text. HTML pages, that is the website we have. We also got a .github that is specific for GitHub things. GitHub it helps you with certain stuff. We've got the Eiffel playground. So if you have a repository and you want to do like test of integrations and do a lot of commits, you don't want to spoil your own commit history, you can play around on the playground repository. We also got the Eiffel community repository template, which is a template if you want to create new repositories. In the specification and architecture area, we've got Eiffel. This is the protocol. And that one is graduated. We also got Sepia, which is a reference architecture, where you basically describing how a system could be built. That is also graduated. Visualization, we've got one product that's hosted within the community by Axis. That is for like visualization of events. Standing events, we've got actually, this is not just one repository, but several repositories for something called RemRem for sending events, and that is actually used. You call the REST call and then you send events. For event processing, we've got Apple Intelligence, and the idea here is you can actually listen to a chain of events, and when those chain events have come, they can actually get a trigger and then call the REST call. For storing and querying, we've got the GraphID QA API. We've got ER event repository implemented in Go. And we also got a specification for other repositories. What is the minimum amount of things you need to comply to actually, for other tools use it? So it's a minimal API specification. For test driving, we got ETOS, Eiffel registration system, I think. This is developed by Axis, so you'll probably have to ask Magnus a little bit more about this one. We also got some smaller starts in protocol integration together with seed events. So here we started with trying to translate Eiffel events to seed events, and also have a demo on how to integrate Eiffel and seed events. And these ones are not fully, but they're getting started. So then this is the kind of a landscape. But let's go on there a little bit to the SDKs. So the first one here is called Random Semantic. It's written in Java. You could probably call it really an SDK maybe, but you can actually generate events. The Eiffel Python library, Python, it's not typed. And it doesn't have multi-edition support. That's the first one, doesn't either. I don't know if we talked about editions, but basically when we release a new set of events, we create an edition. And that is what we call multi-edition support. The most up-to-date is probably the SDK Go SDK. And that one has multi-edition support. And it does now have meta security. So meta security is possible actually to sign events. So you know that the events can sign. We're going to talk more about that and talk later. The latest one is .NET in .NET. That one also has multi-edition support. and also has support for the secure test line movements.